In this video, we're going to take a look at practice quiz for standard 11. In number 1, it says, given ABCD is a parallelogram, fill in the missing statements and reasons. And we're trying to prove that triangle AED is congruent to triangle CEB. I like to highlight those so I know what I'm aiming for. So I'm going to take my highlighter tool for just a second. And I'm going to highlight those triangles. That way it's easy to tell what I'm working on as I'm proving. So give me just a second. You could do it to your paper if you want. So highlight AED and CEB are the triangles that we're working on proving congruent. Okay, so given that ABCD is a parallelogram is my first step. My second step of the proof is filled in. It says AD is congruent to BC. So I like to label AD is congruent to BC in my figure and think of why would I know that that is true. And it's because we're given that it's a parallelogram. We could say opposite sides of a parallelogram are congruent. Make sure my volume's turned up. All right. You could also say definition of a parallelogram, and that would be okay. But I like to write the one that states the property so I can practice the properties. Then step 3 says angle DAC. So let's see. Angle DAC is right there. Is congruent to angle ACB. I don't think I labeled that right. Let me back up. Hold on. So let's label DAC. Ooh, definitely not in the right spot. So it's right there, is congruent to angle ACB, which is right there. And the reason that we know that those are true is because alternate interior angles are congruent. So that's already filled in. And then it says AE is congruent to what? And so let's check it out. AE in the figure is congruent to, and that would have to be EC. And the reason is diagonals of a parallelogram bisect each other. And then the final statement says triangle AED is indeed congruent to triangle CEB because of side, angle, side. Because if you read around the triangle, you have a side that's labeled, you have an angle that's labeled, and you have another side. Over here you have a side, then you have an angle, and then you have another side. So side, angle, side would make the most sense. All right, let's move on to number 2. Number 2 says, Juan made 2 candles in the shape of right rectangular prisms. Remember that that is that fancy term that really just means a box. The first candle is 17 centimeters high, 6 centimeters long, and 4 centimeters wide. The second candle is 3 centimeters higher, but has the same length and width as the first candle. How much additional wax was needed to make the taller candle? Now, we always want to pay attention to things that are in bold, because that's obviously very important. So we're looking for how much additional wax was needed. So let's write down the first candle. And we're going to find the volume of the first candle. We're going to find the volume of the second candle. And then we're going to need to subtract the larger one minus the smaller one. And the larger one is indeed the second candle because it's taller. All right, let's reread. We have the first candle is 7 centimeters high, 6 centimeters long, and 4 centimeters wide. So that would mean 17 times 6 times 4 will give me my volume. When I calculate that, I get 408 cubic centimeters. And then they say the second candle is 3 centimeters higher, but has the same length and width as that first candle. So if it's 3 centimeters higher, I just need to add 3 to that first measurement of height. So 17 plus 3 would give me 20 for my new height. And then 6 and 4 are still my length and width. When I calculate that, I get 480 cubic centimeters. And then remember, we're being asked about how much additional wax was needed to make the taller candle. So we need to say 480 minus 408 would give us 72 cubic centimeters more wax would be needed. All right, let's look at number 3. It says if the volume of a sphere is 365 cubic inches, what is the radius of the sphere? So volume of a sphere, the formula is 4/3 pi r cubed. It's good to write down the formula. And then we're going to fill in the volume, which is 365. And then we just have to solve to figure out the radius. So the first thing I would do is multiply both sides by 3 to get the 3 out from the denominator. And that gives me 1095 equals 4 pi r cubed. Then you could divide by a couple things. You could divide by 4, you could divide by pi, or you could divide by 4 pi. The easiest thing to do is go ahead and divide by that 4 pi, and you might need to just put that in parentheses. And that gives you 87.14 is equal to r cubed. And then you have to go in your calculator to math option 4. Let me just make sure. Let's see, math option number 4. Yes, that is the cube root sign. So math option 4 gives me the cube root sign, and then I could type in 87.14. And so I end up getting r equals approximately 4.43. And they said cubic inches was our volume, so let's say the radius is just 4.43 inches. And that is it for number 3. Let's take a look at number 4. 4 says find the volume of the composite figure. So the composite figure means we have two things put together here. We have a triangular prism at the top, and at the bottom we have a box. So we're going to find the volume of those two things and then add them up. So the volume of this triangular prism would be equal to the area of the base times the height. So the big B means area of the base, which in this case is a triangle. So even though it's sitting on its side, this face of this triangle right here is considered the base of that prism. So we need to say 1/2 base times, or excuse me, 1/2 base times height, because that's the area of that triangle. So the base of the triangle is just the 23 that we could get by looking at the side of the box. So 1/2 23, and then the height is just the 21 inches that goes down the middle of the triangle. And that would give us the volume of the triangular prism. Oh, I need one more thing. Sorry. That is the area of the base. I still need the height of the whole prism. And the height of the prism is right here with the 16. Because if you lay it on the side, that would be the height of it. All right. So when you multiply all of that together, you get 3,864 cubic inches. Okay. Now the bottom is just a box. So we call that fancy box a rectangular prism. So the volume of a rectangular prism is still the area of the base times the height. So this is the area of the base, which in this case is a rectangle. So it's otherwise known as length times width, because that is the area of the base times the height. So length times width times height. All right, so we have length, we'll say is 23. Width, we'll call it 16. And height is the 18. And then when you multiply all of those together, you get 6,624 cubic inches. But then we need the total. All right, so let's total it all up by saying 3,864 cubic inches plus 6,624 cubic inches is a grand total of 10,488 cubic inches. So you just have to find the volume of each and add them up. All right, one last problem. Number 5 says the volume in cubic inches of a decorative box can be expressed as the product of the lengths of the sides as v of x equals x cubed minus 14x squared plus 43x minus 30. The width is x minus 1. Write linear expressions for the box's length and height. So we can put the 1 in our box because that's the root of this factor. Root of x equals 1. Then let's write out our coefficients so we can do synthetic division. So I have 1, negative 14, 43, and negative 30. Let's drop down the first term, which is 1. 1 times 1 is 1. Negative 14 plus 1 is negative 13. Negative 13 times 1 is negative 13. 43 plus negative 13 is 30. 30 times 1 is 30. And then those add up to 0. So remember, these are the coefficients now of your answer, which is 1 less power than what you started with. Because we divided, it gets a little smaller. So you have x squared minus 13x plus 30. And let's say just equals 0. And let's try to factor it, because these should just become factors because we have length, width, and height, which normally look like nice factors. All right, so what would multiply to give me 30 and add to give me negative 13? So we think about 1 times 30. Well, that would be too far apart. We have 2 times 15. That doesn't quite work. We have 3 times 10. All right, so those would work, but we need negative 13. So if we make them both negative, they still would multiply to be positive 30, but they would also add together to give us negative 13. So we have x minus 3 and x minus 10 are the length and height. It doesn't really matter which one, so you just circle those factors. All right, so that's it for practice quiz 11.